Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz, and I'm glad you've taken the chance to join us today as we look at our topic of selecting a clean room or an ESD screwdriver. Now, these tools are currently not available just yet, but we are giving you kind of a sneak peek at these tools and models. They should be available later this year, but we wanted to give you the opportunity to take a look at those ahead of time. Now, this presentation is pretty straightforward. There's not going to be a tremendous time commitment that we'll be using here today, so we'll go ahead and get started. And if you've been with us with any of our webinars, we typically always start out with what are some of the fastening risks that are involved with the torquing assembly process. And first of all, we want to make sure that we're getting the proper torque within the application requirements, because under torquing is certainly an issue that can cause the components to shift and vibrate and cause failure. And the same is true if the fasteners are over torqued. Those can become close to the yield point, and those fasteners then can break, and again we have failure. So making sure we've got the correct torque providing us the correct clamp force for our assemblies are very important, because if not, then we could be introduced to parts breaking, fasteners breaking, and we don't necessarily want that. And these types of issues can also be caused by the operator. The human element that is involved with the fastening process can be one of the biggest contributors to issues that we may see with the process. So having the operator understand what it is that they are doing, making sure that they're doing it correctly, can really help to minimize some of those risks. Now, with proper torque control, what we are really trying to achieve is the correct clamp force. So we want to make sure that the torque that we're providing is stretching our fastener to the correct amount, so we are getting good clamp force. So we stay within the elastic region of that fastener, so we don't go into the plastic region or past the yield point of that. And this is going to obviously make sure that we've got a very reliable process that we can count on, that is going to help to reduce the scrap rates or help to meet qualifications for that particular assembly that we are trying to achieve, safeguarding us against failures as it relates to the torquing process. So the proper torque control is very, very important. Now, some of the manufacturing environmental demands that we may be talking about as we look at the topic that we're talking about today for the clean room environment or for the ESD environment, where we are looking to control dust, microbes, any type of VOCs or volatile organic compounds, where we can help to manage any type of air quality requirements that may be necessary, preventing any type of off gases from adhesives or grease or other polymers, and also so we can control any type of FOD requirements that may be in play, and as well as preventing any type of ESD or electrostatic discharge in that. And so that's going to kind of lead us to our poll question for today. And that question is, what environmental demands impacting tool requirements in your manufacturing process? Is it clean room? Is it preventing ESD? Is it any type of FOD requirement? All of the above, or none of those with that? So I'll give you just a few seconds here to go ahead and answer that poll. Typically, we do have some of our poll music to go along with this, but today we don't have that. So I'll give you just a couple seconds here to go ahead and answer that, and then we will move on with the presentation. All right. With that, it looks like our majority answer is the clean room requirements, followed by the preventing electrostatic discharge right behind that. So thank you very much for participating in that poll. And let's go ahead and continue on with the presentation. So with torque limiting technology as it relates to torque screwdrivers, now there are both electric power tools that are both Cleanroom and ESD available. But today we're talking primarily just the torque screwdrivers themselves. And there are basically two kinds that we can deal with. We either have a preset model or an adjustable model. Now, our preset tools are very good for operations that are going to be very repetitive in their torquing needs. Because an adjustable tool will give you the ability to hit multiple ranges, but there is going to be some time that is going to be needed to dedicate to actually changing those processes to get the correct value that you may be looking for. So the adjustable tool is very good for possible field service work and those types of applications. However, in the environments that we're talking about, maybe a preset tool may be a better choice, depending on what range you may be looking to achieve. Now, the preset tools have a torque range that go from 3 inch-ounces all the way up to 125 inch-pounds. The adjustable tools go from 1.6 inch-pounds up to 80 inch-pounds. So those are the different ranges that are available, and then there are different models within those ranges to get you to where you might need to be for your particular application. Now, the quality standards that are associated with the torque screwdrivers are going to be underneath the ISO 6789 standard, which means the tools must have an accuracy of plus or minus 6% for those to be considered an ISO 6789 tool. And they also must remain or hold their calibration for at least 5,000 cycles for those tools. So those are what we have with our FG series, and that's going to be as well as with the FGA and Cleanroom and ESD models as well. So the one thing that the torque limiting screwdrivers all do is they have some sort of clutch mechanism that is going to allow you to reach a specific torque based off of whatever frictional element that may be used. Now, most torque screwdrivers are going to be using a spring to run a certain rate of compression of that spring. That's going to develop the resistance that's needed to generate a specific torque value. Now, how and what components are used to compress that spring is going to be the real differentiator between different models, different price points, and different manufacturers. And so if we go ahead and we look at some other drivers that are available out on the market, you can see that they slightly vary in how they compress the spring to generate the torque that is being achieved. And so in this model here, you can see there are 3 ball bearings that sit inside this cam mechanism here, and it's sandwiched with this holder or race mechanism. And then as the driver is turned, these ball bearings will hop into the next cam lobe here, and they kind of just continually go around. And so that's how they reset themselves after the spring is compressed. For this model here, you can see that the ball bearings are stationary, and they hop over or push down on these ridges in this assembly as the spring is being compressed there, and then the cam is reset. And the same is true for these other two models as well. So that's how they are compressing the spring. This is a very ball clutch mechanism. And so what makes our drivers a little bit different is that we use a radial cam design, which we have a series of 3 ball bearings that sit inside of the housing here. And as the driver is turned, those ball bearings are pushed into the main housing by the cam mechanism. And that cam then pushes, those ball bearings then push onto a larger ball bearing, which is compressing the spring. This is causing a really smooth and good compression of our spring. And we get a continuous rotational force that is on each ball bearing. So we're not developing any type of groove or any type of loss in wear for, say, a dimpled type of cam mechanism. And so that's how we typically deal with the cam. And again, the differentiator is going to be the componentry and the cam mechanism that is being used that is going to cause different price points within the market. And so as we jump into looking at the tools specifically, the cleanroom standards that are typically used, and a cleanroom basically is an environment that is measured by how many particulates are within a particular, within a cubic foot. And those are different ratings based off of how much is acceptable in that cubic foot. And so they range from class 100 up to class 100,000, which means that they allow that many particles within 1 cubic foot in that particular area or room. So the cleanroom tools that we will be providing are designed to be used in a class 100 environment. So that is the standard that we'll be using with our clean room tools. Now, a typical office environment may have up to 500,000 to 1 million particles per that cubic foot. So you can see that the amount of particulates that are being removed or that are being controlled can really help in keeping that environment really clean, which is needed for a number of different manufacturing processes and applications. So the clean room tools that we're providing here do have a range, again, from 3-inch ounces up to 120-inch pounds. They do have a high-grade low outgassing powder coating to them with high performance, wear resistant inner seals, and also a protective polyurethane sleeve that is going to help contain or not allow any of those particulates that may be generated from the tool to be released into the environment. Now, we also do offer an option to the clean room tool as well. There is an ultra high vacuum grease that can be used as well if that is a requirement that may be needed for your particular application. Again, these are available in either preset or the adjustable tool. And as we look at our demo portion of today, I'll show you what that looks like on one of our adjustable tools. We'll be working with the ESD model, but this will show you how you can set the tool, the different readings, and the display for that particular adjustable driver. Now, as we look at the ESD side of the presentation, or the electrostatic discharge, everyone that is interested in this probably knows exactly what is happening here. But for those that may not, ESD or electrostatic discharge, we've probably all experienced it within our lifetime. If we've walked across a carpet and then touched a doorknob and we get a shock, that is what's happening here. And in that case, as we walk across the floor, we are basically flooding negatively charged molecules. And as those build up and then we touch another conductive surface, that is when our spark happens. But what is really apparent in the electronics industry and stuff, the amount of shock that we may feel within that particular carpet scenario, this happens at a much lower voltage rate, and even 10 volts of ESD can be very problematic for certain components that may be being assembled, and that can cause a real issue with the actual manufacturing of that. So that is ESD, and that's what we're trying to control. And all these typical things are addressed with the operators with either wrist straps or heel straps, so to make sure that the assembly process is well grounded within its application. And so the ESD standards that we've developed these tools to would be the IEC standard and the ANSI standard ESD here. And basically the surface resistance when measured, if it is between 10 to the 4 and 10 to the 11th ohms, that is going to be considered a static dissipative rating. And so that is what we have done with our ESD tools. Here's the test data that we have from 2 different tests that been conducted on the tools for the different models and different ranges. We've done a 2-point probe test and also a handle to tip test on here, and you can see that we are well within those ranges to be considered in that well range of the static dissipative area. So when we look at the ESD driver, it does have the high grade dissipative coating on it, along with the high performance wear resistant seals in it as well. Again, these go from 3-inch ounces up to 125 inch-pounds for the preset models, and then for the adjustable tools, again 1.6 to 80 inch-pounds are the ranges there. And so with that, let's go ahead and we can jump into looking at the adjustable tool, how those are adjusted, and the display options that we have here. And so I've got our FGA 20 ESD tool here. And what you can see is our display, our area where we can turn on the display. We can also then adjust the scale that we may be using, or unit of measurement. And then on the back, we have our lock mechanism here that we can put up to then make adjustments to the actual tool itself. And so let's let's go ahead and we can zoom in a little bit here so you can get a better look at it. And so if I press down on this area, you can see that let's see, that's pretty good right there, I guess. Let's move this over. Perfect. All right. So we're currently set to 3.35 inch pounds. If we wanted to change that unit of measurement, we can come in and we can press on the soft key here again, and that's going to change it to inch ounces. If we press it again, it's going to change it to kilogram for centimeters. Again, if we want to change it again to Newton centimeters, we can do that. Or if we press it again, it will change it to Newton meters. And then we can scroll back around to our inch pound setting. Now, for us to make adjustments on this, if I hold this back and then, let's do it this way. And I make adjustments to the knob, you can see that we are turning up the reading. Or if I turn it counterclockwise, it will then go ahead and change the value. And then go ahead and lock that back. It's spring loaded here, so it will come back to its lock. And then this is where we are for our set point at 3.05 inch pounds on the driver itself. And so this is how that works. Now this display does only display the setting value of this. It's not going to give us an actual value that was torqued. So just to make sure that that is understood within that use of this particular tool. And so you can then go ahead and use it, and it will be at that same torque value. So with that, that's going to kind of wrap things up for us today. And that's going to lead us into any questions that we may have. And so today, I think we have Ashley, who is going to be asking us our questions. So Ashley, do we have any questions? I think we have Ashley, who is going to be asking us our questions. So Ashley, do we have any questions?
Hi, Dave. Yeah, we have a few. First one is, does the ESD coating have a shelf life or is it permanent?
So the ESD on there is a coating to it, but it's not going to wear off. So this is not like a typical ESD spray method that you may think. There's actually properties within the coating itself that do not or that don't wear off. So those are consistent with the performance, and that coating is not going to wear off.
Okay. Another one. Once a preset tool is calibrated, can the torque setting ever be changed?
So it certainly can. The adjustment mechanism is an internal adjustment on there. So the tool itself, basically once it's calibrated, you obviously may not want to go in and change that because then it needs to be recalibrated. But you can reset that tool anywhere within its range after the or with the use of a torque analyzer, or if a calibration lab, or if you have in-house calibration, they should be able to change that. But yep. So if I think the question is if the tool is a preset tool, can it be changed to different values at any point? And yes, it can, but that is done on an internal basis. And so it does take removing the cap and then unlocking a set screw and then making the adjustment and then putting that all back together. So it's not something that the operator can necessarily accidentally change or do without any sort of work that may be involved to do that. So yes, the preset tool can be changed, but it is designed to be set and then used.
Okay, last question. How often does a hand screwdriver need to be calibrated?
So that's a great question. So the ISO specification is it must meet or hold its calibration for at least 5,000 cycles. So at what point does that 5,000 cycles um, take up? Is that 5,000? Does that, if that is done over a year period of time, does that need to be a year? Or if that tool is still being used past the 5,000 cycles, but it is still holding the same values, does that need to be recalibrated? But the standard is 5,000 cycles, but we do have customers that will only send in a tool that needs to be recalibrated if it's going outside of its accuracy statement. So that may be used for longer than a year period. And then we have other customers that will simply calibrate every single tool on a time-based. So every year that tool gets recalibrated and looked at. And then we do have customers that are dealing with very critical type of applications and where they may be looking at their tools at a much higher frequency. And some in the rare instance will actually check their tools before they're used, go ahead and use the tool, and then they check it again right after it's being used, just to make sure that all of that information is correct and being used. So it just comes down to the policy that you use for your calibration, but the requirement is 5,000 cycles. So that is what we're looking at.
All right, it looks like we had another question come through. My tool typically drifts out of tolerance every 12 months during calibration. Is there a good method to determine when the tool is starting to drift out of spec?
So the way to do that is to implement some type of torque verification process, where you may use a torque analyzer or a sensor that could be used out on the floor. That you take that and you go and spot check your tools at a much higher frequency than the year basis. So we do have customers that will do that as well, where they'll take a torque analyzer and a sensor, or a sensor that's built into the analyzer. They'll take that out onto the floor and they check their tools in the interim between calibration cycles, because if like in this case, you get a tool that has drifted out of its calibration, you have really no idea at what point did that go out of calibration, and what might that affect processes down the road. Is there rework involved? Is there notifications, things like that that need to be taken care of? So implementing a validation program to measure your tools at a higher frequency between calibrations can help to eliminate that need. And so if you see the tool is getting close to being out of calibration, you can go ahead and adjust that tool, or you could send it in for repair, whatever the situation might call for.
Okay, and then we have, what is considered to be a torque cycle?
So it's going to be one cam of the tool itself. So as we apply load to it, and then the cam mechanism engages, it's basically that compression of the spring with all of its componentry. That would be considered a cycle.
Okay, and then we had some questions about um, why the clean room drivers aren't on our website. They're just not available yet. Hopefully sometime by the end of the year or sometime this year. We'll keep you updated.
Yep, that's right.
All right, that's all we had.
All right. Thank you so much for joining us today. Really appreciate you again taking the time to join us, and we look forward to seeing you at our next one.